Okay, cool. So, let's dive right into our penultimate week of class. Welcome everyone to another lovely day for coding. We had a real hell of a conclusion to class last week with our Lubridate fun, and hopefully you all carried that on in through your homework assignment. So it would be great, I think, if we talked through the homework a little bit because I know that Lubridate is kind of a lot to take in at once, and since things weren't working super well during class, I figured it'd be good to go over that a little bit. So what did we ask you to do for homework? We asked you to take was it the Gapminder data set? I can't even remember now. No, it was the Mauna Loa data set. And we want to look at, let's see, the mean hourly temperature for each month within that data set after downloading our data and removing some missing values. So does someone want to walk us through their approach for that, please? And you can just pipe up.
I can go, I guess. So after downloading the data set, the first thing I did was I created a new data frame with the date time and in UTC and the local time. And to do that, I created an object called mloa underscore time, but you can name it whatever you want. Then there's an assignment arrow, mloa, a pipe, filter, relative humidity or rel humid, exclamation point, equals sign, -99, and then a pipe, filter, temp C2M, exclamation point, equals sign, -999.9, another pipe, filter, wind speed, meters per second, exclamation point, equals sign, -99.9, another pipe, and then mutate, where inside the parentheses I have date time equals ymd underscore hm, paste, and then I have year dash month hyphen, not dash, hyphen day space hour 24 colon minute. I can explain that a little bit more because I kind of skipped over the syntax in there. And then comma, and then there's a time zone argument where I set time zone equals UTC. And then another pipe, mutate, date time underscore local equals with time zone, date time, comma, time zone equals Pacific / Honolulu.
Wow.
It's really long.
Okay, so I might have messed up your paste thing here a little bit.
Yeah. So after the year, then there's the comma, and in the space you've got a hyphen, then day. Oh no, month should be first. Month hyphen, then day, and then the space. There we go.
And then you included the hour and minute as well?
Yep.
And so if we run this.
It should be min, not minute.
Thank you. Hey, well, something worked. It didn't give us an error at least.
Cool.
And let's take a peek at it. So it looks like it's a little bit too big to look at it on the screen, so we can jump it over to the view. And we can see now we have a date time column, and that is in UTC. And then the date time local, which I spelled wrong, is Okay, and it looks like that's in Pacific, and then the day is a little bit different just because of the time zone difference. Awesome. So Jillian got us set up with what our basic data frame should look like. Jillian, what did you do next to do your aggregation?
So to aggregate, I had MLOA, time, and then a pipe. Mutate, month underscore local equals the month function, and inside that I have date time local, comma, label equals true. Then another pipe, mutate hour local equals hour. Inside you have date time local. Another pipe, then group by month local, comma, hour local, pipe, summarize mean underscore temp equals mean temp C2M, pipe, ggplot, AES, X equals month local, Y equals mean temp, plus geom point, AES col or color, but it's COL, equals hour local, plus scale color Viridis. I use the Viridis package rather than the functions in ggplot itself. But so scale color Viridis option equals C, and that C is in quotation marks, plus labs X equals month, Y equals mean temperature in parentheses C, plus theme black, white, or BW.
Awesome. And let's take a peek at our graph.
Cool.
Terrific. So it looks like we have our months in order and mean temp on the y-axis with our points colored by the hour of day. And as you might expect, the points that are at midnight, so either 0 or 24, have some of the lowest temperatures, and those points that are around midday, where hour equals 12, are the highest temperatures. And then we also get to see that nice seasonal variation too. Thank you so much, Jillian. That was a mouthful, and you explained that really well.
I have a
Are there any?
Oh, sorry. I have a quick question. So, can you go over again what saying for the Viridis color scale option equals C? Isn't that just continuous? Like, is that not already specified by saying scale color Viridis C?
That's a great question. So the scale color Viridis C function is declaring that you have a continuous color scale, but when you use the option argument inside of it, we can even take a look at the help documents here. And what you'll see is there are several options for the color scale that you can choose from. And I believe it goes C through E. Here's options.
You did scale color continuous, not scale color Viridis.
Thank you. Here we go. So you can see the default option is D for both scale, fill, and color, etc. Viridis C, and for scale, color, Viridis C and D. So whether it's discrete or continuous, the default is the option D. And you'll see that there's actually different color palettes you can select from. So option A is the magma color palette, C is the plasma color palette. And now let's take a look at what that actually means. So this was Jillian's solution with this nice ramp from kind of a purple to red to yellow. But if we change the option to A, we end up plotting the same data, but we're looking at a different color ramp, kind of expressed the same way, just with different colors. And I really like C, and I also think I like E, if I remember correctly. Oh, E is kind of blasé. Did that answer your question, Zira?
Yes, thank you.
Are there any other questions on the homework before we move on?
I got a question on the filter at the top. Maybe I missed it in class last time, but I don't understand why we use the -99s instead of like an is.na.
That one?
So,
Oh.
Go ahead.
Sorry, I got excited. Metadata is like my favorite thing. So those are actually, they're not specified anywhere except for the metadata. So that you go in and you see like what columns you're looking at and then what they used as their NA values, and that's where those came from.
Okay, that makes sense.
Anybody else? Looks like there's a lot
Yeah.
going on in the chat here. Oh, go ahead.
Could you really quick go over what the difference between the lubridate function paste and paste zero are?
That's a great question. So paste and paste zero are actually not, they're base R functions. So you can use them without calling the lubridate library. Paste zero is basically a shortcut version of paste, where the default separator between each of your arguments is nothing. So if you use paste without the zero, I think the default separation is a space, but you can declare the separation. So as an example, we can say paste and say homework, comma 9. And if we don't declare a separation, it will by default give us homework space 9, you can see. But if we use paste 0 and then the same 2 arguments for it, it will not put any space between them. And then if you want to get really fancy, you can specify what your separator is, and you can say sep equals dash, for example. And then you can see it puts a dash between those things.
Awesome.
Anybody else? Cool. All right. So last week at the very end of class, we talked pretty briefly about functions and sort of getting started with functions. And if you recall, the basic way that we declare a function is we give it a name. So we can say my function, and then equals, and we'll use the function to say that we're creating a function. And my function is going to be a function of x and y. And then we declare the guts of it with these curly braces. And everything that's inside the curly braces is kind of its own world. So we can say x plus y equals z and return z. And if we run my function of 1 and 2, we should get 3, because this is evaluating x equals 1 and y equals 2. It's adding them together and creating 3. Now, this may not seem very exciting in a simple case like this, but functions can get exponentially more and more complex as you go. Typically, it's best to try to do the bare minimum of like programming for a given function, wherein you're kind of compartmentalizing different tasks. So if you need to go from like a long time series of data to grouped up by months to then plotting, it might be better to have a function that groups your data by months and then another function that plots, rather than having one function that does all this stuff at once. Because when stuff is more compartmentalized, it's a lot easier to work through and debug stuff. And you can also have a lot more sort of versatility in what you can do with code that you've already written, basically. So that is a very brief recap to functions, but I want to get started off with a nice challenge where we're going to make a really complicated function that we're then going to use later in class. So if you could navigate to the course materials and let's see, writing functions. And at the very bottom, there's a challenge. So I'll paste this in the chat. The challenge is to create a function that takes the Gapminder dataset, which is the country, population, and life expectancy dataset. We're going to generate a function that takes a dataset and the name of a country, and with those 2 parameters as what the function is actually a function of, the output of the function should be a ggplot object of the population size versus time. So I will copy and paste the entirety of this function or challenge into the chat. And it's going to take you a little bit of time to deal with this. So if you don't already have the Gapminder library installed, go ahead and use install.packages Gapminder to get that installed. And then, excuse me, start playing around with how you would plot what we're talking about for a single country, and then see if you can generalize that to make a function that would accept the name of a country and automatically plot the time series. So I think it would be best if we took like 8 or 9 minutes to work alone on this, because it'll take some time to fight through it. And then we'll have a little bit of breakout room time and then reconvene. So yeah, go ahead and work on this alone until we'll say 2:38, and then we'll stick you in some breakout rooms from there. And if there are any questions, of course, you are welcome to ask.
This might be a stupid question, but
You muted, Braden.
I'm getting there. There is no package called Gapminder.
Did you wrap it in quotations? Oh, did you use Library Gapminder? You might not have it installed yet. All right, so this was a big function with lots of components and kind of moving parts. So it would be great to hear if anybody did figure out a solution, how they did it.
I've got a solution, but I'll wait in case someone else wants to go, since I already answered
Yeah.
earlier.
Let's let somebody else have a shot. Somebody, anybody?
I can try to take a go at it.
Great.
I think I maybe figured it out, though I was playing around with like 2 different things. So I guess I started by just like making a name for the function overall, which I just called mine country_plot, but it really
like
could
it.
be anything. And then I did function, and then parentheses, I made a parameter called country_chosen, and then specified the data frame. So did like date equals, and then either gapminder, or I'd like renamed my data frame when I was like processing it. So mine had looked slightly different, but yeah, that should work. And then I did the like bracket things.
Mhm.
And then I did I made like a new variable called like D, or I'm not even sure if the step was really necessary, and then I did like pipe, and then I did filter, and then the name of the data frame, which I'm not sure what yours is named.
Mm-hmm.
And then country equals country chosen with like a double equal sign. And then made something called plot, that I did ggplot, data equals the name, I guess what you named E in this case, and then did like mapping equals AES parentheses X equals year, Y equals pop. So you also might be able to just do your pop ace as well. I think both would work. And then I did plus geom line. And then I did return, and then inside the parentheses I did plot. And then tried running that as a function.
Okay. And did you test it with a country?
Yeah, I tested it with Afghanistan.
And when you defined your function, did you set a default parameter for your data frame, or did you have to declare that each time?
So I guess let me see. I was able to just like after specifying the data frame and specifically what I had named Gapminder, it let me plot the country without having to actually specify it again in the function.
Awesome. So let's take a look. Okay, and here we have year on the x-axis, population on the y-axis. Looks like really big numbers. I guess that's just in the millions, but that's still a lot of people. And it's growing as we might expect to see. So great. Thanks so much, Rebecca. I have I think I had 2 things to say. Oh, so you can see on my screen here on line 73, I changed the name of what Rebecca called plot to what I called my plot. And something that we haven't talked about in this class so far, but that I'm glad that this is an opportunity to bring it up, is that when you name a new object, it's best to avoid using the name of a function that already exists. Now, in this class, we've used almost exclusively tidyverse, which means that we've used ggplot to generate our plots. But there's also a function in R called plot, and it's the base R version of plotting. So rather than naming this object simply plot, I named it my plot so that there would be no ambiguity between what R thinks is a function and what we're telling R is an object. Cool, and you set up the default so it already knows what data set to look at. Were there any questions on generating this function?
I had a quick question.
Mm-hmm.
I get the error message back. Don't know how to automatically pick scale for object of type function.
Interesting.
And I had a little bit of an issue creating my own function, so I've just copied what is written here as the example.
And when you use the example, it's giving you that error, or?
Yeah, when I use the example as written, and I'm trying to find if I made a mistake copying it or not.
Right. Can you try pulling it out of the live code and seeing if that works?
Yeah.
Because I wrote the example, so I might have screwed something up. While Braden is testing that, Kirsten asks, there are no error messages when running Becca's code, but no plots are appearing. So Kirsten, did you use the line return my plot as well, or did you not include that?
No, I have that. As far as I can tell, I have the same thing that you have up on the screen.
Has everyone assigned Gapminder to D, like the data frame equals D? That makes sense given everyone's code above.
Yeah.
My function only ran after, I have a one similar to Becca's, but it only ran after I ran like my data frame and then the my plot separately, and then I could run my function. But if I tried to run my function straight through without creating the variables individually first, then it wouldn't run, which is weird.
That is super weird.
I was having kind of a similar issue when I was doing my version, and I don't know if it was successful or not, because I just, no error messages or anything, but just the plots window remained blank.
Could you copy your function code and stick it in the chat? Might be easier to look at it there. Whoa. Kirsten, you didn't get a plot? Are you in your plotting window right now on the in RStudio?
Yeah.
Okay, here's a question. Did you recently hit the zoom button on a different plot? Because if that's still open, the plot can sometimes get sent there.
Yeah, I did hit the zoom to try and see my plot, but it just pulled up a blank window.
Okay.
That's now closed though. And fire again. Same deal, nothing.
When in doubt, go up to the top and do session and then restart our session and then just run all of your code again. That's just like pressing on off on R.
Yeah. So let's do a quick check-in. How about green stickies up if you wrote a function and were able to return some sort of time series plot when you use that function, and red stickies if you're having trouble with that. Okay, so it looks like the majority of us. Oh, Kirsten, did you meet with success after a restart?
Yeah.
Yeah. So Braden and Sierra, try restarting if you're still not having success. And I'm going to clear all the stickies here. And if you still are having trouble, just go ahead and put a red sticky up, and hopefully the TAs will be keeping an eye on that and can hop in if needed. Sound good? Cool. So in the meantime, let's move on to a brief introduction to iteration. Iteration is really nice because sometimes you want to do something 1,000 times, and there's not a convenient tidyverse way of doing that. So for example, you might want to generate one of these country plots for 15 different countries, or for every country in the world, and maybe you want to save them all as independent images and have them all in like a nice accessible format. And you don't want to go through and type out country plot, country of interest equals Afghanistan, country plot, country chosen equals Canada, et cetera, et cetera, et cetera, et cetera. And conveniently, if you're using some sort of programming language like R, you can tell a computer, you know, I want you to do this same repetitive task for each of these individual unique cases. And so that's what we're going to talk about for the rest of class today. And we're going to do that using, at least to begin with, we're going to use a for loop. And the way for loops work is you basically tell the computer, for every item within this vector that contains a series of items, I want you to do a task or a number of tasks. And the way you define a for loop is actually quite similar to a function. So you use the word for, and then in parentheses, you use some sort of placeholder object name. People typically use I, so they'll say for I in countries, or for I in 1 through 10, et cetera, et cetera, et cetera. And so as a little example to start off with, we're going to use for I in a vector that is the numbers 1 through 10. So remember, if we write a concatenated 1:10, we'll get each integer through and including 1 and 10. And I forgot the word in. So this is basically saying for each element of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to do everything that lives inside these curly braces. So you can see it's a little bit similar to a function, but in some ways it's a little bit different too. So for example, let's say for I in 1 through 10, print I. And if we run this, you will see that we get a printed version of each element of 1 through 10. And it's kind of weird, there's a little vector index here indicating that each thing that we're printing is 1 element long, because we're essentially extracting each element of this vector and printing that as its own value. So in the same way that you could print 32 and it would have a little 1 in front of it, each time we print I in 1 through 10, we'll get a little 1 in front of it as well. Now, this on its own might not be very exciting, but you can do lots of wacky stuff with for loops. So for example, you could say for I in 1 through 10, we could say k is equal to I squared, and I want you to give me whatever the value of k minus 2 is. And you can probably guess where this is going. We'll get increasingly large numbers that are 2 less than the square. So 1 squared is 1, 1 minus 2 is -1. 2 squared is 4, 4 minus 2 is 2. Quick maths. All the way up to 100 minus 2 is 98. Now, what's really awesome about this is we can start thinking about this in the context of that function that we wrote. So we could say something like for, let's say I in unique, which is a function that extracts all of the unique values in something. We'll say unique of gapminder by country, print country. No, print I, because we're interested in each individual element of that. And let's take a look at that. Well, I messed something up here. Oh, I had originally called this data set D, so we'll use that here as well. And now you can see we've gotten this. I'm assuming this was alphabetized in the original data set as well, but we get each unique element of the countries column in the Gapminder data set. Now this is where it becomes immediately cool how awesome for loops are. If rather than print I, we said country plot, and we said country of country chosen equals I, we can print, that's going to be like 198 plots. So let's take a look and see what it does. It might make my computer really unhappy. It didn't print any. Let's try, perhaps if we throw a print in there, because right now it's just generating those plots, but we didn't really tell it to print them within the for loop. Okay, now my computer is going to be unhappy because there's way more countries than we can really deal with. So let's make a quick subsetted data frame equals D, and we'll say just for countries, including, what countries should we use? Afghanistan, Canada. Somebody shout out a country for me.
Togo.
Togo, nice. All right, so now we have a smaller data set that's just 3 countries big. And we can say for each of these unique countries in the data set, we will have to specify that our data frame is gap sub. And now we should end up getting 3 plots, none of which have labels, kind of useless. But maybe we can say it was a ggplot object, right? Maybe we can add a ggtitle and call it I. Let's see what that does. Okay, now we have the plot for Togo. We have a plot for Canada. And we have a plot for Afghanistan. So you can see how we took what was originally kind of a simple task and turned it into something that can be iterated and done a bajillion times in a gazillion different permutations, depending on what your needs for a for loop are. So after that brief introduction, are there any questions about for loops before we take a break? All right, awesome. Well, let's take a 10-minute break. If you're still having problems with plotting or loops, I will be around this whole time. So you can go stretch your legs, go to the bathroom, get a drink, talk to us about coding. We're here. Have fun.
All right, thanks for that cue. Sorry you can't see me, so I'll just go ahead and start sharing my R screen. Okay, all set. Thanks for the thumbs up. All right, so Christian got us started on this talk about iteration, which is, for the most part, what we're going to cover for the rest of the day. And to me, iteration is one of the last things that I really could wrap my head around. So I think I will caveat the rest. This is a new kind of syntax, like functions are as well. the question that we just talked about, what actually goes in these curly brackets, hard around, and this idea of fins and kind of putting this all together, I think take time, throughout our journey, because it really can make your life easier once you get the hang of it. So if you can see my live code, we're going to start with iteration, and Christian introduced you to for loops, but just as like a general overview, we are going to be talking about 3 different approaches to iteration, just so you can get a feel for what's out there, and you might eventually just settle on one that you really like, but I think it's useful to at least know some of the language, because of it comes forums. And so when you're Googling around for answers, at least have like a basic. Before that, one of my favorite things in R that is not even code, but makes iteration really easy in your earlier coding days, is just a keyboard trick in R, which I think it's the same key in both Macs and PCs. I know that in Macs, it's just holding down up, and you can see my cursor changes X, and it's a multiple cursor trick. So you can also like Google that. And then you can type and do things on as many lines as you want. And this works in like a variety of fashions. And it's just really cool if you have like a line of code that's all lined up that you've pasted that you want to make an edit on, then you can, rename something form. Isn't a coding nice or chat. It's pretty because a lot, but that's just a quick iterate with keyboard shortcuts. That's just fun. And so you can poke around for that on your, this idea of a for loop. So for this kind of magical value I, which we will just kind of stick with I, because that will be what you'll read if you, but for value in I is a cool example of how this would be super useful for repeatedly making a bunch of different plots. You could, if we have time, and then we could harken back to our cow plot from a few days ago, and then try to fill those all into one massive combined thing of plots. So for loops can be really powerful. And it's worth saying that in addition to plotting, in addition to just printing vectors, like a lot of useful for is also creating new columns or creating whole new data frames with your information. But there is kind of a trick to how to get things out of for loops. As you've seen, there's sort of already the reminder that you need to print whatever your output is, which we're not necessarily used to, or have it returned. So we're going to start with a new example that will show you kind of some ways of getting different kinds of data types outside of for loops. So let's say we want to multiply a column through by 1,000, which the example of what's going to go in this loop is not very advanced, but it will be pretty basic so you can understand some of the syntax. So if we just do for I, so for a number of things in, and let's say we want to multiply a column through by 1,000, and so we need to tell the loop how to extract that information from a column. So one good way to do this, let's say we want to do a column, this empty cars weight, but if you just do I in empty cars weight, so I will, whenever I'm writing a for loop, I will usually just print I to start. So it reminds me what I is actually representing. So I right now is representing the values of empty cars weight. Yeah?
Would you mind zooming in?
Oh, good reminder. Yes. So our I right now is just the same as the vector of empty cars weight. But often when we're working in for loops, we don't want our I to be the value of the column, we want it to be the number of the column because we're wanting to iterate through by rows. So there are a few ways to do this. One is to say use this function sequence along. So I want I to be sequence along MT cars weight, which really could then be any column, because now my I value is just 1 through the number of rows. So in this case, we just want row numbers. You can also do by, this is equivalent to saying 1 through n. So there's a few. So what we want to take E column, and this is really the special trick. We've talked a little bit about, using brackets to index to get particular values outside of vectors or data frames. In this case, in a weight vector, we can use the brackets and I to pull out specific rows of that column. So then let's say our goal is to multiply by 1,000. Down a little bit. So what does I remember? Numbers. And so let's say this is number 3. Running through I is it's taking every row number and then through by 1,000.
Hey, Liza.
And if we, yeah.
We're having a really hard time hearing you. The audio is just super choppy. So if you want, I can pick up and take over from here, or I don't know if there's like a place that you have more reliable Wi-Fi.
I'll speak slowly with this response in hope that it helps. I know that it is painful to hear people with bad internet speak. So I'm happy to have you teach. I've already, my most extreme measure was asking my 5-year-old nephew to stop streaming cartoons, which was my last ditch effort. But I got nothing left now.
Hey, Liza, there's a suggestion in the chat to just call in since you're not using audio anyway.
How do I even do that? Let me take 1 minute to try to do that because that could be cool.
How do we, I have a question about MT cars. I know that's one of those preloaded ones like diamonds but what are we supposed to install that makes it preloaded?
It comes with base R.
Yeah, Logan, so if you just start typing MT cars like in your console or in an R script, it should be happy to autofill it for you with the tab complete.
Thanks.
Could you quickly re-explain really quick how Liza was like moving her cursor over multiple lines at a time? I missed that.
Michael, do you know how to do this? I don't know it off the top of my head.
Let me see. I know for me it's just holding down Option and then clicking and dragging.
For me, it's Control Option and the down arrow.
That does it too. You can also just hold Option and click and drag. But Control Option and then down or up will do it as well. This can be nice if you like need to add something in front of several lines. Nice for stuff like that.
And you would just highlight the text beforehand, and then you write, and then you do the control thing that you just said.
It basically just like it's wherever you would put a cursor, it just puts multiple cursors at that same point on multiple lines, and then you can do. It's just like independently typing at each cursor but you're doing the same thing at all of them. Yeah.
Gotcha.
Yep. One thing I will note is one thing that comes to mind that's like, oh, you might think to do this for comments, but if you highlight lines of code and then you shift Command C or shift Control C, that will comment and uncomment whole blocks. And it's a little easier to do than doing the multiple cursor option. It's very useful. Yeah, that's something I wish I learned sooner. If you have to comment out a whole chunk of code, it's much quicker than doing it line by line.
Yeah, Command Shift C is going to be your best friend.
So if I speak to you now, am I any less choppy? Oh God.
You are super clear now.
Okay, but I have video on both. Okay. And has my R been stalling at all, or is that clear and it's just my voice that's in bad shape?
It's been just audio for me, at least.
Yeah, it's just been the audio.
Okay, cool. Then I'll forge on. And yeah, if it gets bad again, just call me off and we'll reconfigure. Cool. So yeah, the option button for multiple cursors and everything I've said up until this point is just review. So I apologize if that was painful. But we are now with this new for loop working with our rows of empty cars, which you don't need to do a single thing to get this to work for you. Everyone should have access to this data frame and be able to call upon it. And all right, let's say we're trying to multiply through by 1,000. And if we put our print function, then we can see in our results that it's printed out the weights multiplied by 1,000. But the issue is printing is usually not that interesting, or at least for me, I want to put that information somewhere. So printing is easy. The question, how do I get it out? All right, so the trick for loops and extracting information is that you need to create an empty vector of the appropriate length beforehand. Creating an empty vector is pretty easy. In this case, we'll call our vector results, and we will assign it. And so we're going to use this function rep, which is just to replicate NAs. So we're going to make a vector full of NAs, and we want it to be the length of empty cars. This isn't entirely necessary. I know some people who just make them without like a specified length, but it's generally good practice to get it of a particular length, because if you get into really, really long for loops, you can kind of bog down your RStudio and slow things down. So now we have this empty results vector. And instead of printing, what we want to do inside our for loop is we want to actually assign every single one of those outputs into our empty results vector. And pretty much in order to put them in one by one or I by I, we're going to use these same index brackets after results and then assign at what we're asking our for loop to do into each one of those indexes of our results vector. For me, this took forever to wrap my head around. I still kind of play around with it, and it does get even a little more complicated when you are working with data frames. But this is a really good initial way to just kind of get the hang of what for loops are doing. So now, yes, we are still printing this because we printed results, but results now lives in my global environment as a vector that I can call upon again and again. Whereas when you're just printing, you can't call upon that saved vector of values from your for loop. So this concept of creating an empty vector is super important for loops. Does anyone have any questions on that?
I actually do have so this creates an entirely new table, whereas like mutate would add a column onto empty cars, right?
Yes. So there's definitely the question in this example specifically is like, why would I go to all this trouble when I can just mutate and create a new column? The reason is that like this kind of quick toy is that usually for loops, you can have lines and lines of sort of complicated guidance, all that happen within this loop. And then maybe you want to spit out something at the very end that's a new column with it that has so many conditions or different functions or elaborations involved that you couldn't have done that in a mutate call, or at least not within a single step of a mutate call, and then you can't repeat it potentially if your repeats aren't exactly across rows.
Another thing
a
thing I would add about that too is that because I just inside your loop will have like a value of 1, what it allows you to do is it allows you to use that value of 1 in many different ways. So you could use that 1 to index a row from empty cars and a row from a totally separate data frame, and allows you to get the first row from those two at the same time. So it allows you to like, it's flexible in that all it's doing is setting I to some number and then doing all the code inside. So that's super flexible. And you can use that across different data frames, different data sets, lots of different ways like that. And then the other use, which many of you probably won't need at any point, but it can come up, is that sometimes you're doing things where the previous value, the value you're calculating right now depends on the previous value. Like if you're doing a population growth model, where you need the last population size to figure out how to do the calculation this time. And in that case, you have to do a loop of some sort where you're sequentially going, okay, get the last value, calculate something, update that to that, our current population value, plug that in. Then when the loop runs again, your previous value is now the last value, and you repeat like that. So that's another way that for loops are really, really useful.
Yeah, and I was looking at the examples online and trying to think of an example that could show you how applicable this is, but they're usually pretty convoluted, or at least all the ways I use them are really layered and drawing upon multiple, like Michael was saying, different data frames, different concepts, pulling from like different parts of my code. And so it's hard to show simply how useful it can be, but I think if you start asking yourself how to repeat stuff, this will come up and eventually become useful. And there's also a power to ours that if it's not useful for you, then that's fine. Not everyone will use these, but they're good to know they exist. And I guess the next type, which for loops are sort of one of 2 base R ways of iterating. And the next 2 that we'll go over, I think, are probably a little easier, and you may or may not potentially see their applicability more readily. Unless we have other questions about what's happening with this vector creation or what happens within for loops. Okay, so next I'm going to briefly talk about 2 functions that operate very similarly, but as is sort of par for the course in this class is that we will kind of compare base R to dplyr real quick. So often you will come across this apply series, which you'll see kind of this whole series, lapply, sapply, there's mapply, etc., which are all different base R functions for iteration. And then there is also the map function, which also has a number of extensions that belong to dplyr. In this case, they use really similar syntax, so I'm going to describe them side by side. I actually have rarely ever seen map come up, and maybe that's just because I haven't been looking for it, but I do see when I'm Googling around a lot of apply functions being used, and I've been really intimidated by them and continue to be. But they're, again, another good thing to just kind of have on your radar. So this is also a good way to harken back to functions, which Christian just reviewed, and you'll see that iteration and functions often go hand in hand. So remember the function format, if we're still sticking with this really basic example of multiplying through a column by 1,000, a function would be written like this, where the function of x inside curly brackets is just x times 1,000. So that's a function way of writing what we did up here in a way that can be sort of iterated through. Now in apply and map, we often use things called anonymous functions. How can I spell anonymous? Here. Which look really similar to functions, but they are just nested within the apply or the map functions. So we're going to first go over sapply and the different arguments that go into that, which will be applied. So in sapply, you're usually going to give it an x value, or the thing or the column, the vector that, or the data frame that you want to do the iterative work on. And then you're going to give it this function that will be anonymous, and then what you want that function to be. If you search for this function in your help, what you'll kind of see this list that lapply returns a list of the same length as x, and then which is the result of applying function, is also often abbreviated uppercase fun. But I find that instruction on how to write anonymous functions is like this assumed thing. So they'll usually just say fun and then assume that you know what to do with that. So this is where you sort of have to combine your function writing knowledge with sapply. But what this would look like is you would say, okay, I want to apply, and by S in this case is a simplified apply function, and it's sort of my preferred of the apply functions. But if you go with sapply, and we're working with, in this example, we'll first do it with mtcars weight, and then we'll move on to something a little more powerful. So with mtcars weight, which is my x, I'm going to create this anonymous function, which looks almost exactly like this function format above, but without the curly brackets. So it looks like a function without curly brackets, basic is how I think of it. If someone has a more advanced understanding, please let me know. But so function of x, no curly brackets, but then I'm going to tell my apply function what this function should do, which is just x times 1,000. And if I execute that, you'll see that with a lot more elegant of code, we got the same thing that our more lengthy for loop did above. Still, why wouldn't we just do this with mutate? Because really the whole point is to use apply functions beyond just one column, but instead do things across multiple columns or across multiple rows. So we can do this same situation function, x times 1,000. But instead of just doing this on the weight column, you can give sapply or the apply functions an entire data frame. And you'll see this is the whole thing, but it has actually multiplied every column through by 1,000. So instead of, what we'd often find ourselves doing is, like copying and pasting this, or copying and pasting your mutate and just changing the column name every time. But once you start getting to a lot of columns, or your data gets bigger, your functions and your code gets more complex, there's a lot of error that can happen with copying and pasting. And so it's really nice to be able to perform these across entire data frames or across selections of a data frame. So if you just wanted to do this, say, to columns, that's how I would do this, like 2 through 5, maybe not all of them, but you can tell which columns of mtcars you want to perform this function across. The good news is the map function has really similar syntax. I actually don't use it enough to know where the differences are, but at least at the basic level, they're pretty similar. But I know someone asked about this in a previous class or in a previous discussion and has seen some of their professors using it. So it really looks almost exactly the same. Map is the function call, but then you still use your x, and then you can write your anonymous function here. And so this first example with map, it spits out the same values, but in what feels like maybe a more obnoxious way. You see each column and then sort of spit out as a single vector, but it's not appearing as a data frame as it previously did. So map actually has a series of extensions that can be added on, which if you search in the help function will give you a long list of them. But it says map always returns a list, which is what this previous data structure was. But you can use this whole series of specifying what kinds of values are going to be returned, which is kind of harkens back to what like week 2 of why knowing your data types is important, because these sorts of, especially when you get into apply, knowing what data you're putting in and what kind of data you're getting out can be some of the details that are a little more frustrating, and it's quicker if you know what they are. But in this instance, I want a data frame out, and so I am going to do map df. And look, because this map function is actually a part of the tidyverse, or is at least a part of the per package, then it actually spits out a really nice tibble as my data frame, and we've now iterated across all columns using the map function. Any questions about those two?
One thing I would add is, I don't know if people saw that there's another map variant that was map 2.
Yeah.
I don't know if you were going to cover that or not, but
we're about to get fancier.
Oh my goodness.
Yeah, but good point. So good segue is that this also still maybe doesn't feel as exciting of like, I can almost do this. Like this doesn't seem like that bad copy and pasting, or, but both map is more advanced and the apply functions can get more advanced. And I only know the tip of the iceberg. So, but like, so for example, let's say that we want to work with more than one variable. Because right now we're working with either a whole data frame or just a single column, but if we want to create more complex functions where say there's an X and a Y, we can also do that with map and apply. So more than one variable. All right, so in this example, we're going to still be using the mtcars data, but we're going to create a function that's going to combine 2 of the columns with some text to tell us about the speed of different kinds of cars. So to do this, I mentioned mapply is a multivariate apply, and map2 is roughly the equivalent. I'm a little, oh gosh, hesitant to say that, but I feel like they work pretty similarly. So if we want to get more advanced, we'll start with our mapply, and I'll show you the same in map, which is that we can now use both an X argument. So in this case, I'm going to take the row names. Let's actually look first at mtcars. So you can always do view with a capital V, which is annoying, mtcars, to take a look at the mtcars data if you're not very familiar. It's nice, and we're working with it now because these are all data types of numeric. And this is, I don't prefer data frames like this, but sometimes you will see data frames that utilize row names as a categorical variable. So what's happening here is that you have the different types of cars, but they are not a data type themselves. They are a row name. Sure, but so we're going to reference that if we want to reference our row names in relation to another one of their columns is what we're going to do now. So row names of mtcars, which is just what we just looked at, is our X, and if Y is our mtcars miles per gallon, then we are going to write another anonymous function, but this time we are going to have both an X and a Y in our function. And without our curly brackets, we're going to use this paste function that Christian reminded us of to put these things together. So paste, where we're going to take our X, which we've assigned X to our car names, our row names of cars, and then we're going to paste that with the word gets. Continue to paste this against Y. So we're doing car names gets the value of miles per gallon, and I'll label that for you. And if we execute this, and there's one more function argument I'm going to put that's specific to mapply, which is usenames equals false, which mostly this isn't as elegant as I wanted it to turn out, but if you usenames equals false, what you'll see is that this has gone through both rows and pasted them together, which is not something you could really do with a mutate function row by row. So where our apply functions really get us is that we're able to match rows to rows in a more dynamic way. And we can look at each one of these column names and how many miles per gallon they get in sentence form, which is just a toy example, but sort of shows you how you can build more advanced functions and use multiple columns to work with both apply. And it's in map 2 is similar. And what this function is, so you start with map 2, just like with map, like when we queried it, it has this long kind of string of different kinds of data types that you might want your output to be. In this case, I'm going to call upon character because we're producing what are pretty clearly character strings. And I'm actually just going to put the exact same arguments in here. So I think this is one of the few occasions where base R and dplyr are actually almost identical, except this is not working because it actually is not identical and it doesn't like to assign x's and y's. But using the map function or the map2 function, we get the same result. So these are base R and dplyr ways of applying different functions across a whole data frame, multiple rows, and creating more complex functions. Michael, is there anything you had to add about map2 or features that I am not as familiar with because map is not my my strong point?
Basically everything you can accomplish with map, you can also do with apply functions. Now, I use the map functions a lot. The reason being the fact that there are different functions with different names and different formats, I think it makes it much clearer what you're trying to accomplish with that function. Like, what do you want out of it? If you're doing map 2, it's very nice because there are 2 inputs. There's a version P map, which allows you to do as many inputs as you want. You can do an X, Y, and a Z input. I like it a lot because of that. Yeah, I mean, I was using them this morning to like do fit a model, the same model to like 100 different data sets, and I used all map functions for accomplishing it. And I like them a lot. I think the other thing that's nice about them, if you just decide to dive in like feet first, which I just did at some point, it really forces you to make your code more flexible and more extensible in a way that I think almost always ends up paying off in the long run. I've never found that taking a bit of time to make like a mapping pattern to do something, every time I run into a problem, it's easier to solve because you have a bit more of a structured framework to work within rather than trying to do everything one-off or off the cuff.
Yeah, Christian, if you have, because I think I actually am sort of too comfortable in my for loop world, even though I know it's less efficient, and then gravitate more towards apply because I feel like there are more references, but I also might not be looking for map references.
I almost exclusively use lapply and then coerce everything back into the format I want it to be. Which is not an efficient solution, everyone. Don't do that. But it does work.
I would look up, I think they're referenced on the website, either under the references or like more materials section, but Jenny Bryan has some fantastic per map tutorials that are extremely useful. And I think both show you a good understanding of how to work with it and give some really useful examples for how to use them to do things like, like fit the same model to a bunch of different parameter sets.
Yeah, and so it's sort of pick your, I know people have already expressed some opinions of what, or at least what I've seen in homework, that some people are already in camp dplyr, some people are pro base R, and that's, your personal call, and sort of sometimes it's whatever you're more comfortable with first, but some truly are more elegant. So I guess take the time to figure out which one you'd rather become more fluent in when the time comes, I would say. Any other, I don't know if TAs have a weigh in on this. Because if not, we'll get to just sort of our last topic, which will again be looking at some base R versus dplyr approaches to conditional statements. And I think conditional statements, I don't know about other people, but I use, they're like my bread and butter. And so I think they're really good to sort of end on, and also end up usually being used in combination for me, often with function writing and iteration. So the logic is pretty simple, but they're good to have under your belt if you haven't already made yourself familiar with them. And let's see, I will say that I'm sure there are more than this, but there are three, in my mind, 3 conditional statement approaches. And I'm only gonna go over 2. There is an example on the website for a if, and I'll usually call it, nope, not that, if else, which breaks up if else statements into sort of, if this condition, do something, and then you can write out an else condition, which means do something else, is one approach. There's then a confusingly similar function that is all one word called if else. And then there is a case when function, which is in dplyr. Out of personal, I don't dislike this if dot else, but I think that for sort of quick early purposes, if else and case when are a little easier to wrap your head around. So we'll start with that, where generally the logic of all of these conditional statements, no matter which ones you're using, is that if X is true, then do Y, and if X is not true, then do Z. And you can layer these so that there is, these can build up. It doesn't just have to be 3 arguments, but or rather just 2 arguments, but the very basic level of is, if this is true, then do that, and if it's not true, then do something else, or don't do that. So what this looks like in code form is, let's say we have our mtcars data set again, which we'll just look at to remind ourselves. And okay, so we have this miles per gallon column value. And let's say you were working with your data and you wanted to make a categorical variable where you translated certain ranges of miles per gallon into an efficiency category. So make an efficiency category with miles per gallon, and you want to just say you're either high or low efficiency. A quick way of doing that you could say mtcars, and remember we can use mutate, but you can also just create the $sign and name a new column, whatever you want it to be. And so mtcars $efficiency, and we'll start with the if else syntax, which is if else. So this idea, it tells you up here that your arguments are test, yes, and no. And so our test, actually a good pre-moment is, I want to know where to split this. So I like the summary function to give you a feel for some of the distribution of your data. So if we look at a summary of miles per gallon, we see that the mean is 20.09. So we could use that number, or we could just call upon the mean function. But let's say, all right, if mtcars miles per gallon is greater than or equal to, I'll just call upon the mean function of mtcars miles per gallon, or I could just write in 22.8, whatever that may be. So this is our first statement. If this statement is true, meaning if our value in mtcars is greater than the mean of mtcars, then I want this to be high efficiency, and then a comma, and still within this first argument. And if not, then I want it to be, I want to call it low efficiency. So we can check that out. I also don't know if we reviewed this. I really like the table function just for a quick look at categorical counts. But good, so it is now created, where we've now created this new variable called efficiency, and we've been able to categorize them into high or low based on whether or not they fell above or below the mean. This is really just with 2 arguments. But let's say you wanted to layer these on with 4 arguments. So let's reinspect our miles per gallon. If we wanted to make another shot at this, efficiency 2, we can layer these if-else statements to say, if empty cars, miles per gallon, I mean, really, maybe not 4 arguments, is less than or equal to 15.43, which is the first quartile, then make it low. And now instead of just doing your else argument, you can sort of do or if, is sort of how I think about this. You restart if else again, and then you will give it another potentially true statement that it will query after it goes through this first round of conditions. So first, if it's lower than 15.32, make it low. And then if not, let's look again and say, is it greater than 15? I don't know where I got 3.2 from, 4.3. And let's say if MT cars MPG is less than, we'll go with the third quartile, 22.8, then we want to make it medium. And then because you've already covered these 2 bases, if it's less than this number, it's low. If it's between these 2 numbers, and it's medium. You can just assume that your last argument is going to be high. I sometimes am not keen to do this and will write out the exact parameters and leave the last one as sort of like an error, in that way I can check to make sure that my if-else statements are actually correct. But we'll go with this one for right now. And we can check out MT cars efficiency 2. And you can now see that we've categorized them into 3 categories. So these if-else statements can continuously be layered upon one another. They can get pretty clunky though. And maybe one of my biggest pet peeves in R is the tab indent of each next if-else statement. But that is the base R approach. It's a little clunky, but it totally works. And I like the way that the logic is spelled out. But in our very last couple of minutes, I will just show you the case when option, which you can decide for yourself which you think is most useful. But this uses sort of our tidyverse piping logic, which will make it look way more elegant. So we can start with empty cars, we can pipe it through, and we can mutate. So instead of assigning with an arrow, we will mutate, and we will just say efficiency, we'll say this is efficiency 3 equals, and now we use this function case when. And I will say my complaint is that if you actually look up the case when in help, I mean, it just describes to you really exactly what should happen. So it's not something you can sort of glance at and see the arguments. It's just a series of dots. But if you can get over that, then all these arguments are really saying is that we're going to put something on the left-hand side, which is the condition, and we're going to put something on the right-hand side, which is what I want this new value to be if the condition is met. So we don't need to specify our data frame every time because we're working in sort of this dplyr piping language, which is potentially the greatest beauty of case when, I think. But so you can put in the same conditions. If miles per gallon is less than or equal to 15.43, we're then going to use this tilde to distinguish the left side from the right side, and we're going to call it low. We can then specify our next argument that will look the same as above, 15.43, and miles per gallon is less than 22.8. And again, this tilde, if these conditions are met, we want it to be medium. And the last argument is, instead of just leaving it sort of blank, or not really blank, but we don't specify a condition, it just assumes if none of these conditions are met, then we assign it high. The way this is sort of set up in case when is that if true, so sort of if this last condition is true, or if you haven't met any of the previous conditions, then you will be assigned high. And that should be the complete situation. And here you can see that this has added efficiency 3 now to our data frame, and it should look the same as efficiency 2, but we got there potentially, I mean, it's kind of up to you which of these you think is more elegant looking. This one I think requires fewer words, but might not make as much sense if you're talking it through to yourself. So this is sort of the last of our like big core information for the course. And if you go on the course website, then you will see at the very end of this last lesson that there's a quick example of like knitting it all together, which knitting's a poor word because that's actually a function that you can do and we'll talk about next week. But you can actually kind of put all of these concepts together, especially function writing, iteration, and you can throw conditional sort of statements in there as well. And this is where, at least I think, stuff gets really exciting, as like feeling empowered by knowing your code enough to like really get your data organized in a more efficient way. And like Michael was saying, I think it is really worth the time, at least, you know, not right away. The learning curve is steep and there's a lot to learn before you get into writing your own functions and iterating all of your code seamlessly, but starting to think about your code in ways of how can this be iterated? You know, how can I simplify what it is I'm asking R to do so that I can repeat it over and over is, I think, like the goal of every coder. And so that's just sort of something to put on your horizon as you sort of advance your way through coding adventures. And with that, we have just a minute. Thanks for bearing with me with the divided language barrier. But does anyone have any questions? So we don't have a weekly homework assignment this week. We just have your final assignment, which I think we said last week, we will talk about RStudio next week, but having not spoken about it yet does not bar you from starting to think about the actual work that will eventually end up inside in our Markdown document. So there's a lot of stuff that starts kind of from probably week 1 or 2 and goes from there. And so just like at least glancing it over to prepare yourself for the kind of time that it might take. And I think that will end it for the day. As always, I'm happy to hang out and you can ask any questions if you need. But thanks for hanging in there with us today, as always.